Laboratory exercise number 10. Simple harmonic oscillators. Objectives. The activity aims to period of oscillation of a spring mass system. Resources needed for the experiment. 1 set 2.2 meter linear track, 2 pieces harmonic springs, 1 piece super pulley with clamp, 1 bar 50 grams mass, 1 box set of masses, 1 piece 2 meter long string, 1 unit top loading balance. Procedures for the experiment. Part 1. Measurement to find the spring constant in theoretical period. 1. Measure the mass of the card and record it in Table 3.1. 2. Install the feet on the track and level it. Install the end stop about 1 meter apart. Clamp the pulley at one end of the track. 3. Set the card on the track and attach a spring to each end. Attach the other ends of the springs to the end stops. 4. Tie a string to the end of the card farther from the pulley. Wrap the string under the card, then run it under one end stop and over the pulley. 5. Attach the mass hanger to the other end of the string. Adjust the pulley so that the string runs parallel to the track. 6. Let the mass hang freely and wait for the card to come to rest. Record the mass of the hanger and the resting equilibrium position of the card. 7. Add mass to the hanger. Record the hanging mass and the new equilibrium position of the card. Calculate the forces applied by the hanging mass. 8. Repeat this for a total of 5 different masses, being careful not to overstretch the springs. 9. Plot force versus position. Draw the best fit straight line through the data points and determine the slope of the line. The slope is equal to the effective spring constant, K, without 500 grams K equals 12.42 N per meter, and with 500 grams K equals 12.10 N per meter. 10. Using the mass of the card and the spring constant, calculate the theoretical period of the card alone and with added mass. Theoretical period of card alone equals 1.27 seconds. Theoretical period of card with added mass equals 1.74 seconds. Part 2. Measuring the experimental period. 1. Displace the card from equilibrium and let it go. Time 5 oscillations and record the time. 2. Using the mass of the card and the spring constant, calculate the theoretical period of the card alone and with added mass. Theoretical period of card alone equals 1.27 seconds. Repeat this measurement 5 times, using the same initial displacement. 3. Add a 500 grams mass to the card and repeat steps 9 and 10. 4. Calculate the average time for 5 oscillation with and without the 500 grams mass in the card. 5. Calculate the period by dividing this average times by 5 and record the periods. Experimental period equals 1.27 seconds. 6. Calculate the percent difference between the measured and theoretical values. Card alone percent difference equals 6.7%. Card with added mass percent difference equals 3.57%. Here is our data gathered in the experiment. Observations. Increasing mass will cause the increase in oscillation. Every mass added to the hanging mass will change the position of the card. The hanging mass is directly proportional to period. Spring constant is inversely proportional to the period. Conclusion. In this experiment, we have concluded after analyzing the factors that affect the period of oscillation device. The equations that determine the period of oscillating system. In one cycle, the system moves from starting position through maximum and minimum points, and returns to starting position, identical cycle. Therefore, the oscillation period is directly proportional to mass and inversely proportional to the constant of spring. A stiffer spring with a constant mass decreases oscillation period. Increasing the mass increases the period of oscillation.